Hi guys, welcome to Memo's tutorials. Today we are looking at the metals and nanometals. So we just need to look at the general properties of metals to say how do they behave. Firstly, metals, they are very good conductors of electricity and heat. Metals have got high melting and boiling points, which means they are solid at room temperatures. I'm sure you can agree with me. Metals, they are solid at room temperatures. And these metals, they can be hammered into different shapes. This simply means that they are malleable. You know, you can find them as a needle, as an axe, as a wheelbarrow, as a door handle. They can be changed into any form, right? That means they are malleable. Another thing, they can be drawn out to make wires. I'm sure you can agree with me. The cables, they are made up of metal wires, our electrical wires, you know. And then these metals, they also look shiny when they are polished. You know, that's what last means. They look shiny when polished. These metals, they make a ringing noise when struck. You know, this means they are sonorous. You know, when you hit a metal, you will regret. It will make a very annoying noise, okay, a ringing noise, you know. And then they also have what we call high density. These metals, they actually react with oxygen to form oxides, and their oxides, they are basic, right? They react with oxygen to form basic oxides. What about the nanometals? The nanometals, they just have low density. They look dull in the solid state. Nanometals are not malleable or ductile, meaning they are brittle. Nanometals, they break up very easily. That means they are brittle. They also do not conduct any electricity or heat at all. These nanometals, they've got lower melting and boiling points. Many are gases at room temperature, though we have some nanometals that are not gases at room temperature. For example, a wooden table, it's not a gas, but then it looks dull. It will be dull unless it has been edited somehow. And then these ones, they react with oxygen to form oxides that are acidic. Take note, they form acidic oxides. But as for the oxides of metals, they are basic oxides, right? That's a very important thing for you guys to note. And then now, what about the reactivity of these metals? This is the very important part. These metals, they will react with water, right? For example, we've got sodium and potassium. They actually react vigorously with cold water to form alkali solutions. They form hydroxides in a hydrogen gas. Potassium and sodium, they react vigorously. That's a very important thing for you guys to master. They don't just react, they react vigorously. But as for calcium, it will react slowly with cold water. The reaction with calcium, it's going to be slower, but still it's going to form a hydroxide and hydrogen gas. But what about magnesium? Magnesium reacts vigorously with steam. Take note, it will only react with steam to form a white oxide and hydrogen gas. It's not going to form a hydroxide. It is just going to form a magnesium oxide. That's calcium hydroxide. That's sodium hydroxide. As for magnesium, it's going to react with steam and it's going to form a white oxide in hydrogen gas. The white oxide is the magnesium oxide, right? So during this reaction, a lot of heat and light energy is emitted. And this magnesium in water, magnesium will never react with cold water, right? Though what we call calcium reacts with cold water, but though to be slowly. But then sodium and potassium, they react vigorously, right? Take note of those differences. As for zinc does not react with cold water, but it reacts more slowly with steam to produce zinc oxide, which is yellow. Take note of that. Zinc oxide, which is yellow. It's yellow when hot and white when cold. Take note of that. That's very important, right? Zinc, it will not react with cold water, but it is going to react with steam. And when it does react with steam, it will form a zinc oxide molecule compound and a hydrogen gas. But then as it reacts, zinc oxide, it's yellow when hot and it's white when cold. Take note of that. That's very important, right? What about iron? Iron, it will react with steam but does not react with cold water again. And as for iron, rusting occurs very slowly in the presence of oxygen. So iron will react with water to give us iron oxide plus hydrogen gas. Take note of the formulas there and how they balance their equations. As for copper and lead, they do not react with water and steam. Copper and lead, they will not react with water and steam. Okay, those ones, they will not react at all. What about the reaction of metals with dilute acids now? We looked at water. What about acids now? You know, sodium and calcium, they will react, but explosively with dilute acids to form salts and hydrogens. Meaning the reaction is very explosive, you know. It's a very explosive reaction. For example, we are reacting potassium and hydrochloric acid. We get potassium chloride plus hydrogen. But this reaction is very explosive, right? It's a very dangerous reaction. As for magnesium, aluminium, zinc, and iron, these ones, they will react mildly with dilute acids to form salt and hydrogen. For example, magnesium and hydrochloric acid, it will give us magnesium chloride, which is our salt, and the hydrogen gas. Zinc will give us zinc chloride and our hydrogen. Aluminium will give us aluminium chloride and our hydrogen gas. Again, copper and lead have no reaction with dilute acids except with concentrated acid. Meaning to say, for you to have copper and lead reacting, you must use concentrated acids, right? And then we need to remember something. This is a note to be considered, that when we want to test for hydrogen, we must use a burning splint, and when hydrogen is present, the blending splint will explode with a pop sound. That's a sign that hydrogen gas has been produced. When you test for the presence of hydrogen, you just use a burning splint and a pop sound must be produced there, right? That's the reaction of metals with, we've looked reaction of metals with water, with acids. Now we move on to reaction of metals with oxygen. Sodium again, it is going to burn with a bright yellow flame to produce a white oxide. Take note of that. Sodium will burn with a bright yellow flame to produce a white oxide. So it's sodium plus oxygen, we get sodium oxide. Take note of the colors. Calcium will burn with a red flame to produce a white oxide. Magnesium will burn with a bright white flame to produce white solid oxide. And then aluminum burns when strongly heated to form a white oxide. Doesn't have any color when burning. And then zinc burns with a yellow to produce a yellow oxide when hot, white when cold. I'm sure you remember the zinc guy to say the zinc oxide is actually yellow when hot and white when cold, right? The iron powder, it burns with bright yellow flame to produce a blue-black oxide. Take note of these colors. They are very, very, very important. As for copper powder, it will burn with red glow to produce a black oxide, right? Copper oxide is black, and then as it burns with a red color there. Okay, so with that being said, now we can be able to look at the reactivity series to say which elements, which metals are more reactive and which ones are least reactive, comparing to their reaction with oxygen, their reaction with water, their reaction with acids. So they've made a conclusion that potassium is the most reactive, followed by sodium, followed by calcium, magnesium, aluminium, zinc, iron, lead, and copper. So these metals, you need to cram them, you need to know them very well. Okay, you need to know that potassium is the most reactive, followed by sodium, followed by calcium, followed by magnesium, followed by aluminium, followed by zinc, iron, lead, and copper. This you must know and know very well, right? So on our next lesson, we are going to be looking at the speed of reaction and also how we can measure the speed of any reaction.